Okay, so in this video we're going to do a few more examples with modified box plots and identifying outliers. We're going to use Minitab this time to do some of our calculations and to make our box plots. So in this example we're going to look at gas prices. If you go to the statistics resources, the data files module in D2L, you'll find this. It's part of the zipped file of data files, but so it gives weekly gas prices at service stations in the Midwest. We want to compare the distribution of prices over the 3 years that are included. Okay, so we're going to go over to Minitab, and I have this data file already open. So it should look like this when you open it. We've got year, and I think it's 2002, 2003, and 2004, and price per gallon. So you can reminisce about how cheap gas prices were back then. And we're going to go to graph and Boxplot, and we have one quantitative variable with groups, so with a categorical. So we're going to select with groups, and we're going to hit OK. Our graph variable is the price, and our categorical variable is the year. And this is one because we're grouping things by what year they are in. So we're going to hit OK. And we're going to get our 3 box plots, and you can see that, no surprise, our median gas price rises from 2002 to 2003 to 2004 by a fairly consistent amount. And you can see hopefully here how the box plot makes it really easy to compare these. That we start out at a median of about $1.35, well, apparently $1.35, and then we go up to about, probably was about $1.47, and yeah, I was a little low, $1.49.5, and then we're up at about $1.70, $1.69.4. So we can see really quickly that the median has increased. We can also see that the variability in the gas prices has increased as the years went on. So in 2002 we had the most consistent gas prices, except for these outliers down here, but our interquartile range is definitely the smallest. In 2003 it got a little bit bigger, and in 2004 it was the largest. We can also see that if we don't include the outliers, it looks like 2002 is maybe pretty close to symmetric. It's a little hard to tell because while our whiskers, I think actually the right one's a little bit, the top one, the right one's a little bit longer, but then it's kind of lopsided the other way in the middle, so it's a little hard to tell. 2003 is a little bit skewed to the right. 2004, we definitely have a longer whisker on the high end, the right side, than we do on the left, so it's definitely skewed to the right. So you can make those kinds of comparisons. And meanwhile, we can answer our question here: in which year were the prices least stable? That was definitely the third year that was included. That was 2004. Now, I wanted to show you one thing with the class data set. So we're looking at the spring 2007 class data here. And so far we've done making box plots when we have one quantitative and one categorical variable, but we can do it if we have 2 quantitative. So like we could say, I want to compare the distribution of time spent exercising versus time spent on the internet, let's say. So in this case we're going to select multiple Y's because we have multiple quantitative variables. I'm going to hit OK. And what did I say? So we're going to do exercise minutes and internet minutes. And here we have our plot. Nice. All in the same. It's much easier to compare because they're on the same scale. And you can see very quickly that the class as a whole, the 3 sections, spends more time on the internet than they do exercising. There are some exceptions to that. We've got, but in general, I mean, the Q3 on the exercise is under 44 minutes, and the Q1 is not much lower than that. So, yeah, I would, our median here was 67.5, and here our whiskers go up to 68. So basically everything but the outliers of the exercise is below the 50% or yeah, the 50% mark on the internet usage. So we can say the typical time spent on the internet is much more than the typical time spent exercising. It's also more variable than the exercise time. Both distributions are skewed to the right, but internet time is much more strongly skewed. So you can make those kinds of comparisons. All right. Now we're going to go back and do one more example. This one is about hockey. So here we have Gretzky, Wayne Gretzky. This data file gives the number of games that he played during his 20-year hockey career in the NHL. So we're going to make a histogram. We're going to decide if we want to use the mean or the median to describe the center of the distribution. I'm going to, the median is 79, and we need to figure out if we expect the mean to be higher or lower. We're going to have Minitab make a box plot and see if there are any outliers, and then we're going to calculate the fences to verify that there indeed are outliers. All right, so I've got let's see here. I got to get it open. Okay, so we're going to go to File, Open, and I'm going to go look for Gretzky, I think it is. Yep, there we are. All right, and you can see there's just one variable here. It's just the games played. So if we look at a histogram, simple histogram, games played is our graph variable. And you can see, there's, the question is whether or not these two low seasons where he played less games, if they're outliers or not. But it looks like it's skewed to the left. Let's see if we increase the number of bins maybe to 10. Maybe it'll look a little, yeah, that looks a little bit better, right? Unimodal, skewed left. These look like they're probably outliers. So, which one should we use? Should we use the median or should we use the mean to describe this? Well, since it's skewed to the left, it's not symmetric. Remember, the mean is not very resistant to skew, but the median is. So we really want to use the median to describe the center of this distribution. And because it is skewed to the left and the mean is not resistant, it's going to get pulled down towards the tail. So we expect the mean to be lower. And we can go verify that. Stats, basic stats. And we're going to display the descriptive statistics for games played. And we can see that our mean was 74.3, where our median was 79. So our mean is indeed lower than our median. So we'll write that up here. All right, so we should use the median to describe our center because our distribution is skewed to the left. So use the median. Right, and we expect the mean to be lower, and it was. Were there any outliers? So we need to make a box plot. So we're going to go back here, and we're going to get a graph, and we're going to look at the box plot and figure out if those 2 points are outliers or not. And of course the answer is, maybe not surprisingly, yes, they are outliers. So we've got these two outliers down here. You can see the skewness that we saw in the histogram. You can see that same skewness in the box plot because the left tail, the lower tail is, or lower whisker rather, is stretched out, becoming a tail, and in between the interquartile range, in between Q1 and Q3, it's also lopsided in the same direction with the median much closer to Q3 than it is to Q1. All right, so we're going to calculate, we're going to verify those fences. So we've got Q1 is 73.25 and Q3 is 80. So we're going to use that information. So yes, there were low outliers. All right, so we've got Q1 was 73.25. Q3 was 80. So that, remember, our interquartile range is going to be the difference between those two, which in this case is 6.75. We're going to calculate 1.5 times the interquartile range. and that's going to give us 10.125. And then we need to calculate our fences. So we've got Q1 minus 1.5 IQR. So that means we're looking at 73.25 minus 10.125. That's going to be 63.125. So anything below 63, and that little bit is going to be an outlier. And then the fence on the other side, Q3 plus interquartile range, 1.5 times interquartile range, 80 plus 10.125 is going to be 90.125. So there's our fences, and we definitely have those two data values that were 50, slightly less than 50, and so they are definitely outliers. And I'll just write a note here to remind us that it is pulled, the mean is pulled towards the tail. Pulled towards the tail. There we go. Sorry about that. All right. And that is it for this. Thank you for watching. I hope that helps.